Hello everybody. In today's video, let us discuss about the curl of vector field. So the curl of vector field is defined as line integral per unit area. Right? Now, mathematically it is written as curl of vector field. Let A be the vector field. The cross product of operator del and vector field. The cross product of operator del and vector field. Okay. So, I think all of you are familiar with the cross product calculations or multiplication. Right? Now, how we will write this cross product? Del means what? I dou by dou x plus j dou by dou y plus k dou by dou z. You know that. Now what will be the a? I ax plus j ay plus k az. Right? Now how we will write in determinant form for this? The determinant form curl a is equal to I j k. I components under I only, j components under j only, k components under k only. Similarly this also ax, ay, az. Then how we will do this? I. How we will write? We will remove the row and column and we will do the cross multiplication. Dou az by dou y minus dou ay by dou z. Next, minus j we will write, but I am writing plus j. So, as usual, row and column. Actually, if I write minus j, this into this I have to do. But here I am writing plus. So, first what I will write? Dou ax by dou z instead of dou az by dou x. Minus dou az by dou x. Right? Dou ax by dou z, dou az by dou x. Next, plus k. As usual, column and row. Now this into this into this. Dou ay by dou x minus dou ax by dou y. Right? Now let us prove this. Okay. So let us go for the derivation of curl of vector field. For this, consider xy plane. Right? Xy plane. In this, let us consider a rectangle ABCD of sides with length dx and dy. Right? Consider the center. Let A be the vector field at the center. Okay? A be the vector field at the center. Resolve A into two components. One along x direction, that is ax. Other along y direction, that is ay. Right? Now consider the midpoints in AB face, BC face, CD face and DA face. Let us name them as, let this be P in center. Now Q, R, S, T. Right? Now first, the rate of increase of AX along y-axis. Along y-axis I said. What we will write? Dou AX by dou Y. Similarly, the rate of increase of AY along x-axis. I said x-axis. Underline that. Dou AY by what we will write? Dou X along x-axis I say. Dou X. Right? Now next. First let us write the increase in magnitude of AX in going from P to R. Now this we are considering AX along P to R. From P to R. What we will write? From P to R means what? Y direction. So dou AX by dou Y along Y direction P to R into distance. Right? What is the distance? P. R is the distance. P to R distance is PR. Then what will be the value of PR? So, the total distance dy. So, P to R will be dy by 2. So, dy by 2. So, this can be written as 1 by 2 dou AX by dou Y dy. Right? Now, next, let us write the value of AX at R. What we will write? The value of AX itself plus the increase in magnitude of AX from P to R. Right? So this is equal to value of AX itself is AX plus the increase of magnitude of AX from P to R is half dou AX by dou Y dy. Right? So now at R, the value is what? AX plus half dou AX by dou Y dy. Okay? Right? Now, the direction of this is, we have to indicate the direction also. Along x-axis, no? So, direction will be AX component. So, direction D to C or RC. Direction is R to C. Right? Similarly, AX at T, at this point, what will be? AX instead of plus minus half dou AX by dou Y dy. Again direction along x-axis. So direction will be along TB. So this will be the direction. Direction will be along TB. Similarly, let us find out AY at Q. In a similar manner we are writing, that is AY plus half. Instead of this, what we will write? This dou AY by dou X dx. Right? So the direction will be, so here first let us write this. Here at T, the value of AX is ax half dou ax by dou y dy. Now at q what we got? Ay plus half dou ay by dou x dx, and direction y direction. So in such a way. Now similarly ay at point S, instead of plus here we will get minus dou ay by dou x dx, and here the direction is BC, and here the direction will be y direction, no, SD, right? Direction is SD. Okay. Now next, let us add all these four. Okay, all these four. How we will add means, now what we want? The line integral, the definition itself is saying line integral per unit area is curl. So we have to find, no. So first we have to find the line integral along the boundary ABCD, right? The boundary ABCD. Once here, for your, instead of turning the page, I'm writing here. Here our P was there, right? Q, R, S, T was there. This is the directions of AX. Okay. This is the directions of AY which we wrote. Right. Now first what we will write means, now the total distance along x-axis dx we wrote, and this face we wrote it as dy. Right. So first what we will write, AB, we have to find out the line integral along the boundary ABCD. AB into component of vector along AB plus, all we have to add. Next, this is ABCD. Next, BC. Right? BC into component of vector along BC plus, next CD. CD into component of vector along CD plus DA. DA into component of vector along DA. Right? So first, the component of vector along AB, what we find it? We find it as, I'm turning the page once I'm showing you. So this is AB. AX minus of half dou AX by dou Y dy. Right? Now this is BC. AY plus half dou AY by dou X dx. CD. AX plus half dou AX by dou Y dy. DA. So DA is AY minus half dou AY by dou X into dx. I'm writing this only here. First, the component of vector along AB, AX minus half dou AX by dou Y dy into AB, the value of AB I said as dx, plus, next BC. Along BC, what we got? The component of vector along BC, AY plus half dou AY by dou X dx into, what is the value of this BC? dy we said. Right? Plus, now CD, this one. AX instead of minus plus, half dou AX by dou Y dy dx. Right? CD is equal to AB is equal to dx. Similarly, CB is equal to DA is equal to dy. Now next, along DA, instead of plus we will get minus. Minus half dou AY by dou X dx into dy. Okay. Now, so, now these last two terms I'm taking with negative sign. Okay, the last two integrals I'm taking with a negative sign. Why I'm taking with a negative sign means the components of vectors are in opposite direction. Are in opposite direction. The components of vector are in opposite direction. Right? So now, first ax minus half dou ax by dou y dy dx plus ay plus half dou ay by dou x dx dy, right? Minus, now I'm separating this ax dx minus into plus minus half dou ax by dou y dy dx minus ay minus minus plus, okay, half dou ay by dou x dx dy. Now this ax minus ax dx cancels, plus ay dy minus ay dy cancels. Now here what we are having, minus of half dou x by dou y dy minus of half dou ax by dou y dy dx, right? This becomes what? Minus, no? 2 of half dou ax by dou y dx dy. Okay. Now next here plus, here plus. Plus term I am writing first. So 2 of half dou ay by dou x dx dy. 2 strikes off. What we will get? Dou ay by dou x dx dy minus dou ax by dou y dx dy. If we take dx dy common, dou ay by dou x minus dou ax by dou y dx dy. I took dx dy common. So now, line integral. What is the definition of curl? Line integral per unit area along which axis I have to say? Dx dy I said. Here we got dx dy. Dx dy is the area along z axis. So, along z axis. And unit vector along z axis is k. So, now what we will write? Dou ay by dou x minus dou ax by dou y dx by dy and area along z axis dx by dy. Okay. So this is equal to the unit vector along z axis is k. So dou ay by dou x minus dou ax by dou y into k. Now similarly, we can write along y axis. Okay. So along y axis what we will get? So along y axis, the j, y axis unit vector is j. So what we will get? Dou ax by dou z minus dou az by dou x j. Similarly, along x axis, what we will get? I is the unit vector along x axis. So dou az by dou y minus dou ay by dou z. Right? How to remember means? The area along x axis is x, y, dx, dy. Area along y axis will be dx, dz. area along the x-axis will be dz dy. In such a logically, you remember how to write y and x-axis. Now let us add all this. You will get the final result. The curl A you will get. What is the curl A? First let us write I. Dou AZ by dou Y minus dou AY by dou Z I plus J dou AX by dou Z minus dou AZ by dou X J plus K dou AY by dou X minus dou AX by dou Y into K. This is nothing but we can also write it as del cross A. So this is about the curl of a vector field. So now let us check whether this answer is right or wrong. Here what we got? Z, Y for I. Okay. And X, Z for J. Y and X. First one what? ZY. Where we wrote ZY. Next AX. Next YX. So we proved or we derived the expression for curl of vector field. Thank you for watching my video. If you might like video, share it, subscribe it. Thank you.